Hi folks, I'm going to take a look at LayerZero V2 and deploying an Omnichain Fungible token to two blockchains and then wiring them up using Foundry. So I've already created the project and the files here, and I'm pretty much just going to run through it. There's not a lot of solidity to be written in this project. It's more about Foundry and interacting with the contracts after you've deployed them, okay? So the basic process of doing this is here, OFT underscore process. You need to set up your Foundry project initially, so forge init. Then you need to install the LayerZero contracts and the OpenZeppelin contracts. I've just added in to do git add and git ignore after each command here because you'll need a fresh git repo in order for not to throw an error when you do the next command. Okay. Then we're just going to do our OFT contracts. So I'm going to deploy one to Sepolia testnet and one to the Mumbai Polygon testnet. They're basically token contracts, so they're fairly trivial. The only thing is that you've extended them with the OFT standard, which gives you access to LayerZero V2. Deployed into the test nets. Then what you need to do is this is what I call this wiring up. So you wire them up so as that the Sepolia contract is able to communicate to Mumbai one and vice versa. And then you just check that they're set as peers and that they know about each other. Then we set options. So this is we set on forced options, and then we're going to quote send and send their token. So I'll speak about these when we get to them. These are kind of the bulk of the stuff. So this is all about deploying and then wiring it up, and then this here is about actually sending our tokens from one blockchain over to the next. So first things first, I'm just going to show you in the docs. So I'm using the OFT quick start and the V2 docs of LayerZero's docs site. This is the OFT token here that they say to do in the demo. I've changed it slightly for my implementation, so I'm not passing anything through to the constructor on my one because I just want it to be the same each time. It's not a big deal to do it the way it's just changed slightly. So as you can see, you're passing the name, symbol, the LZ endpoint, and the owner into the constructor here, and then it's passing on. Whereas in the one I'm doing, if you see here in the Sepolia one, I'm pretty much just baking them into the contract itself, just for demo purposes, really. So let me see. So I have this one here, and the only difference between the Sepolia and Mumbai one, again, they are just, if you see OFT here, OFT is an ERC20 token. So there you go. So it's actually an ERC20 token, and then it also has OFT core, I should say. So it is a token, and then OFT extends the functionality of the contract to allow you to interact with LayerZero V2. So let's open Mumbai as well, and as you can see, there is very little differences. It's just on the name of the contract here that Sepolia and Mumbai differ. What I'm doing here is the only thing I'm doing in the constructor is minting 100 ether or 100 tokens in our case of our token here, and 100 tokens on Sepolia as well. So the first thing I'm going to do is deploy our contracts. I've actually written out the commands already in this make file, so I'm just going to show you the make file. The contracts themselves, as I said, they're fairly trivial. You just import, you just say is OFT, and then it's the OFT standard. That makes LZ send, LZ receive available on your contracts on both sides, and then it's really about deploying them and wiring them up and getting them to work that matters after that. So I'll have a look here. I have this make file here where I have all my commands pre-written. I've done these already just to make sure that I get them working. It did take a while to get them working in Foundry, but here we are now. So what I'm going to do is I'm just going to run through this, and what I'll do is as we're doing it step by step, I'm going to try and explain what I'm doing. It doesn't matter too much here because you can kind of see Forge Create, you're creating your contract on Sepolia, and you're passing in your private key. Okay, so it's not a big deal. It's not rocket science as to what's going on here. We're deploying to Sepolia, we're deploying to Mumbai, we're verifying our contract on both chains. I actually think it'll probably, because I've deployed the contracts already, the bytecode will be the same. So I'd say it'll probably be pre-verified. And then what we do then is we set our peers. So we're getting into the LayerZero kind of wiring up here, and then we check, and then I'm just checking total supply of that they both have 100 in them. Then we go down here and we pass through our options, and I'm going to tell you what's going on here with these options and how to pass them through, because it starts getting a little bit tricky down here when we are trying to pass in tuples and stuff like that. Okay. So I'm going to open up my terminal, and the first thing I'm going to do is deploy to both blockchains, or both testnets. So make deploy OFT to Sepolia. Let that deploy, and we will get our transaction hash, and the address of our contract that's just deployed. Let's give that a second. There we go. So deploy to is our actual deployed contract. I'm just going to copy that, and I'm going to switch over to the ENV. Now I have the ENV set up, and I'm just going to show you what's going on here. I do have a private key in here. This is just a burner, so I'm going to scrap it afterwards, and there's nothing in it apart from a little bit of test funds anyway. I'm going to be shutting down any of these Infura RPCs anyway, and same with Etherscan. I'm going to delete the keys afterwards. So none of this will be usable afterwards. Don't let anybody see your RPC keys or your Etherscan keys, and especially not your private keys or anything like that. So I deployed these earlier on. I'm just going to replace this, okay? So that's the Sepolia one that we've just deployed. And you'll also see here that we have Sepolia bytes 32 pair, okay? Now, this was the sticking point for me, not getting it into 32 bytes. As you'll see here, this is, we'll do it on the second one, FF, all the way up here as far as 10. You'll see that it's 0x, and that's the address of our Mumbai OFT on the last time I deployed it. And with a bytes 32, it adds this pattern through to it, okay? But if you do this in Foundry, I'm just going to clear this real quick. There's a cast command where you can go cast 2 bytes 32, and you put this in. Now, be very careful. I made a mistake. I took this here and I pasted it in here, and I was getting errors in my my OFT transferring between chains, and what was happening was that the padding in Foundry actually right pads the zeros onto it to make it a bytes 32, whereas what we really need is we need a left padded, okay? So I'm going to take that out, and I'm going to copy this, and I'm going to go here. So this contract is, let me see, I think it's actually from E down, so I'm just going to do this. I'm just going to take off OX here, and that should be right. So just be very, very careful that your bytes 32 has the zeros padded to the left rather than the right. It'll save you a lot of headaches. Okay, now we're going to deploy to Mumbai. Let me see. Oh yes, because I'm on the Mumbai chain. Just 1 second. Okay, so I have topped up my Mumbai, my Matic on my Mumbai account. So let me see if this works. There we go. Okay, so happy days, that's deployed. I'm going to paste that into the Mumbai OFT address, and then again, like I did last time, it's going to be one off. So we'll see. Let me see. I think this is correct. Take that OX out of it. Yep. Oh. Okay, they have the same contract address. I hope that's correct. I think it possibly is alright, but I'll just check it afterwards. So both of our OFT is deployed to Sepolia and Mumbai, and then we have the bytes 32 here for interacting with the contracts after this. Now 1 second. So and then we have our Etherscan, Polygon scan keys, and our RPCs. So switching back over, we don't need to look at the solidity anymore. I'm going to go back over to the make file, okay? So in our make file, we have deployed our OFTs to both networks. What we're going to do now is we're just going to verify the contracts. Again, I think they probably are already pre-verified due to the fact that we have that the bytecode is already, it's going to see it as identical to stuff I deployed earlier, to be honest. So, but on Sepolia. Yeah, already verified. It's going to be the same on Mumbai. Great, that's done there. Okay, so the first thing we're going to do in relation to the LayerZero stuff, so that's all standard, deploying the contracts and verifying them. The first thing we're going to do that's LayerZero specific is setting the pairs. So again, this is really wiring the contracts up to make them aware of each other. Word wrap. There we go. So over here, I've actually taken some screenshots of the LayerZero docs, and if I go here to the set peer function, you'll see what we're calling here, and what it's actually doing. Okay, so set peer. Let's maximize that. We get rid of this. Here we go. So it's not quite large enough there, but the set peer function, and what it does is it takes in an EID, so it's the endpoint ID and the peer. So the endpoint ID is actually, it's like a 5-digit identifier that tells the LayerZero contract what blockchain you're going to. So on Sepolia, our EID is going to be the Mumbai EID, and then the peer is going to be the contract that we just deployed to Mumbai. Okay, so that's what that does. So what we're doing here is, if we go back to the makefile, you'll see that I'm doing I'm calling cast send to the Sepolia OFT, and for a set peer it takes in a UN32 and a bytes32. And this here you'll find in the LayerZero docs is the Mumbai endpoint ID, and again, like I showed you a few minutes ago, this here is going to be the Mumbai bytes32 peer, which is going to be left padded address of our contract, and then we're using our Sepolia RPC and our private key. So I'm going to do that, and I'm going to wire up. I'm going to make the wire. I'm going to set the peer on Sepolia to be the Mumbai contract. So I'm going to make set peer on Sepolia contract. Here we go. I'll do the same on the Mumbai. There we go. So that's the both the peers set, and then what we're going to do is there's a function on the contract as well, just to check that the peers are correct. So again, we're saying is peer, are passing in the EID, and it's the same information that the same params I should say that we're passing through, and we're just saying to the contract, hello, is this here a peer, and it'll send back a bool, true or false. So I'm just going to do that real quick. Down here, it's clear. I would say make check Sepolia peer should come back true. There we go. And then we do check Mumbai peer. Mumbai peer again should be true. Okay, good stuff. So what we've done now is we've deployed our contracts and we've wired them up to know about each other through the LayerZero message passing. Okay, and we'll do now. Again, this is just a contract specific, but we will just check on our contracts to make sure that we have 100 tokens in each. So check Sepolia total supply. Again, we're just calling the contract, calling total supply in the contract, and it returns a UN, so we should see 100. Yeah, so 1 E20 or 100 E18, and that's fine. And then we'll just do one by. It's going to be the exact same anyway, so. But I'll just check it for completeness. There we go. Once again, 1 E20, which is 100 E18. So that's grand. So that's the basic wiring done now. And what we're really doing now is we're getting into the ticket things now, and this is kind of where it got a little bit hairy, and I bumped into a couple of issues, but I have them ironed out now. I'm just going to put on word wrap so we can see the whole commands. So the first one was setting first options. Okay, so what we're doing here is we're calling out to the Sepolia contract, and we're calling this setting first options function. And what that takes in a struct, which is a tuple, and it's an array. It takes in an array of them. Okay, so I'll just show you very quickly over here. Set a first options function, and this is it here. I'll maximize that and scroll up. So you'll see here, set a first option. What it does is it takes in this first option param array. Okay, and what that is an array of these structs here, and they have the endpoint ID. Again, same endpoint ID. So for Sepolia, we send the Mumbai one. The message type, which I'll just scroll down here. And for our one, we're just doing simple send. It's not going to be send and call, which is composed if you're doing something on the far end of Mumbai and passing it on to another contract. And then the options, which is a bytes array of gas fee options. So I'm just going to click back over here and show you where we are. Back to makefile. Turn on word wrap again. So as you can see, we're passing it in, and this is the way to do it in Foundry. So it's a little bit complicated, but what you're doing here now is you're saying, so this set enforced options, it takes a struct, and the struct has these three members in it. So again, if you see there, there's a struct, and it has EID, message type, options. So it's a struct with UN32, UN16, and bytes. And as you can see in our make file here, we're saying that it takes in a struct with a UN32, UN16, and bytes. And again, and as this part here, you can see that I have the square brackets there to say that this is an array. Now, as we're only sending in one struct in the array for what we're doing, but you can send in multiple structs if needs be. So once again, it's well, we're just sending in one struct here of these. It actually does take in an array of structs. Is what it takes in initially. So even if you're sending in one, you have to send in one struct in an array, and this is the syntax to do it. Okay, so you want to have your set of force options within brackets, and then within there you have your tuple or your struct, and your square brackets behind it to denote that it takes in an array of these. And then over here, what you're doing is you have your Mumbai endpoint ID. We're saying 1 because again that was simple send, and then this is our options, our message options. Now I'll go over that now in 1 second, but just for the time being, we'll stick to what we're doing. What we're saying is, here's a struct in here, and it's an array of structs, so we wrap it with our square brackets, and that's how we get that to work. So I'm just gonna do that now. Oh, sorry, I'm just gonna do that now. So what we'll do is we will actually pass in set the enforced options on Sepolia. So make set enforced options on Sepolia contract. Just wait for that to run. There we go. So that's gone through. So now we've set our options on it, and I'll just quickly talk about this here, okay? So, I think I have it here. So the set of force options, let me see. So send. So I don't think I have a picture of it here, but set the force options, set pair function. I don't have it here, but what I'm going to do is, in test, I'm going to show you what this actually is here, okay? So they have a few different functions. I've chopped up the test function just to get this out here. And essentially what you're doing is you're calling, you're using this options builder, and it gives you back a bytes variable with the options in it, and then that's what you're passing in here as your third variable, okay, into this, okay. So if we go back here to this, you'll see that what we're doing is we're getting option builder, new options, because it's going to be an options variable, and we're saying add executor LZ receive option. So this is all part of the options builder, and I'm saying in this one 1,500,000 gas and then 0. You will see this in the docs, and it'll explain what it is. But for our purposes, this is how I've done it. And if I just do this and I do forge test, you'll see here that there it ends in 16E360. And if you see here, well, I think I've passed in 200,000 here, but it's the same anyway. If I was to do, if I got back here for 1 second, I think that's 200,000 I'm passing in. Save that and try one more time. There we go. So it's 30D40. 30D40. So I'm passing in 200,000 gas for the LZ for this for the LZ receive, whatever the thing is. 1 second now. Yeah, for the options. Okay. So that's the format for doing that, and we've already done it. Okay. These quotes here, I'm probably going to skip these. What they do is basically, because your contract needs to get an estimate of gas on the destination chain. You can call these quotes to say, here's the payload that I'm sending, how much is this going to cost? And I'll just run it just to show you really quickly what it does. We do make get send quote on Sepolia, And there we go. And it comes back and it tells us that this is how much way that we should send in order for our transaction to go through. Okay. But what I'm going to do is I'm going to skip over here to the final send one, and I'm going to break down what exactly is going on here as well. Okay. Right. So for this here, we're calling the send function, and this is where we're actually going to send our tokens from Sepolia to Mumbai. I'm going to have a look here at this send. I've taken the screenshots from the LayerZero V2 docs. I've taken a picture of the function and the param. So this is the function here. Get rid of the CLI and maximize that. So this is the meat of what we're doing to send it over. We call it send, and what we do is we pass in a send param struct, a messaging fee struct, and an address. And then it goes in here and it calls LZ send over to our destination chain, or through the LayerZero, should say, the executor relayer, and over to our destination chain. Now, the trick here is just building up this command in Foundry, because it was quite difficult to get the gist of, but it's working now, and I'll just try and go over it as best I can, so that and I will put this up on GitHub, so that if somebody wants to use it again and they can kind of deconstruct it and see what way I've done it, but hopefully I'll explain it now as best I can. So the params are here. So these are the params that we passed in. As we said in the function, it takes the send function takes in this struct, and this address. Okay, and go back here to the params. So what we're doing is we need to build these up in our command, and we need to say that we need to, and as you can see here, we have UN32 destination ID. Once again, it's going to be the Mumbai. 2 is going to be the destination address, so the OFT contract on Mumbai. Then these amounts, the amount to send in local decimals and the minimum amount to send, I've matched these up to be the same when we're sending them over. Then the extra, now for these ones, extra options, compose message, and OFT, we can send these as blank, which is just 0x. Okay. Then on our fee, what we're going to say is the native fee and the LayerZero token fee. Now, just to be clear, when we're sending our transaction, we need to make sure that the native fee here in our messaging fee struct is the same as the message.value that we're sending. Okay, so if we're sending a native fee, if it is say we go back here and we say that, let me just do this again. Get the quote in Sepolia. If we're sending through that much way there, as part of our in this native fee here, as requested, we say okay, it's going to take this much, it's going to take that much way in ETH to send it from Sepolia over to Mumbai, into this. I'll just get rid of that. Into that native fee. You want to make sure that we're matching it equally with the value that we have here in our command. So they need to match up. And the reason I show you there is because I was getting this error. This is one error that I bumped into. So we're getting this error here on Sepolia, and it was saying that not enough native. And when I looked into the function to see where this error was being emitted from, I found it in the function here, and hopefully this goes big enough, and it was in the pay native. And I noticed that if you see here, message.value, if message.value does not equal the native fee, not enough native. Okay, so what was happening was I was initially wasn't sending the same amount of ether here, so 0.01 ETH, and also when I was sending it here in this second one. So you need to make sure that they match up. So that there, if you go to ETH converter and you convert 0.01 ETH into way, that's how much it is in way. So make sure that they match up the value that you're sending in message.value and this one in here as your messaging native fee. Okay, so to go back to where we were there on, yep, I go back here to this. So we're looking at the params, and then the refund address is just an address. Okay, so just keeping an eye on this. So we have a struct that has UN32, bytes 32, UN256, UN256, and bytes and bytes. Okay, so I'm just going to quickly go back here to the make file, and you can see cast send. Okay, and the first thing I want to do is I want to send a struct. So struct is wrapped in these purple braces here. So that's our first struct. Okay, and again UN32, bytes 32. UN256, bytes, and bytes, which matches up with this, and that's how you that's how you do your message, or sorry, your function selector there when you're doing it in Foundry, okay? And then the second one here that you send through in the params is going to be this messaging fee struct, which has a uint and a uint. So if I go back here to Makefile, you'd see our second one. So we have a comma there, and it's a uint and a uint. And then our last one is a refund address, which is just an address. And then you'll see comma address, and they're all wrapped because they're all wrapped obviously in the send function, and then there's one tuple, a second tuple or struct, and then the address, okay? And that's just the function selector. And then what we're doing is we're actually passing in the information here, okay? So our first thing we're doing is uint32 here is the destination ID, and then the second one is 2, okay? So destination ID is uint32, and then bytes32 is 2, okay? What we're saying here is that's our endpoint ID, our destination ID. uint32 is that, and then for our who we're sending it to, we're actually sending it to the Mumbai contract, the OFT contract that we have there. And again, bytes32 is our Mumbai contract address. We left padded to make it a bytes32, and then as you can see here in the params, we have a uint256, uint256 for amounts, okay? What we're doing here is we have our amount. So this is actually, I think that's 10. It's going to be 10 tokens. So 10 and 10, and then you'll see here that I have these as empty. So we don't have any extra options, any compose message, and any OFT command. So if you see that's our first struct there. That's being passed through, and again, it's wrapped in quotation marks, because that's how we're sending it in. If it was a uint or something like that, you could just have it sitting on its own. In fact, public address is just there. That's just sitting on its own. It's not wrapped in anything. But when you're wrapping these structs or you're sending them in as tuples, you have to make sure that you have them wrapped in your quotation marks like that. Okay. Then for the next one, it's a uint and a uint. And what we're saying here is this is again matches our gas, and then 0 is the LayerZero token fee, which we're not using the LayerZero token for this. We're just going to be using native ETH, okay? And then again, the public address here is the refund address. And after that, it's just RPC URL, the private key, and then the value of the Ether. Now, I'm just going to run this command. So we're at the business end of it now. So I'm just going to do make send tokens from Sepolia to Mumbai. Give that a second to run. Okay, so it's actually it's hit our contract there. I'm just going to take the transaction hash, and I'm going to switch over now to the browser and just show you on Sepolia Etherscan, Mumbai Polygon scan, and also LayerZero scan what's happening. Okay, so here we are in Etherscan Sepolia testnet, and this is our contract address here. And as you can see here OFT Sepolia OFTS. And if you go down here, you can see what we've done earlier on. So we created our contract, we set our peer, we set our force options, and then we're after doing a send. I'm just going to replace it. I'm just going to refresh this. So you go 2 minutes ago. So it hit our contract. Here's a transaction hash. See here, yeah. So it's after transferring it to our over to our LayerZero endpoint, and I'm just going to switch over now. So what we'll do is, so we take our transaction hash here, and we go to LayerZero scan. Now I've already checked it out there, but I can see. So you can see if we do this. This is our transaction on LayerZero, and as you can see, it's confirming at the moment. The first thing it does is you'll see it saying it's kind of a purple text and say in flight, and then it's saying confirming, and then I'm not sure what the last status is. I think it might be sent or confirmed. So what's happening now is we've done the work on our Sepolia contract, and it's handed it off to the LayerZero endpoint on Sepolia. What that's doing is that's passing it through the executor and verifier in the LayerZero network, and passing it over to our Polygon Mumbai. So you can see what we have here. We've set our peer, and that's all we've done on this. And we'll just see in a few minutes we're going to see that receive is going to be set on this. And at the moment, if we click in here, So there we can see, we can actually see that the tokens have actually hit the contract because we've only had 110. So what we've done here now is we've 10 transferred over, and if we click back over here and we go back to where Sepolia, click in here, this should be 90 now at this stage. There we go. So you can see now that we initially deployed one to Sepolia, we deployed one to Mumbai, and as you can see, after wiring up our contracts and constructing our command line, our Foundry commands, we've now passed them between the Sepolia testnet and the Mumbai testnet, 10 tokens, and that's it. So that's an overview of how to do it in Foundry, and a couple of the gotchas that you might come across when you're doing it.